Okay, continuing on, let's look at a few more examples of this substitution technique. So as in the first one, I had mentioned usually use the ugly piece, and you're always looking for its derivative. Well, if we look at u here, we don't quite have its derivative because we have 2x plus 2 dx, right? But it's so close. We're just off by a multiplier of 2. If this was 2x and this was 2, then we have it. So that's an easy fix. We'll multiply this by 2. But since we multiplied by 2, we also multiply by 1/2. Right? Since 1/2 times 2 is 1, and I didn't technically change the original problem. And notice this here is now du, because if I either factored this, right, 2 times x plus 1, or if I distributed the 2, I'd have 2x plus 2. No matter how you look at it, we're set. So let's make this substitution. We have this 1/2 out front, integral. All of that was u, so u to the 6, and then everything that's left was du. Once again, the hardest part in these is usually finding your u, right? Find u and du, then easy integral from there. So we have 1/2 u to the 7th over 7, or 1/7 u7, right? However you want to do it. So overall we get 1/14th, but now back substitute, so x squared plus 2x plus 3 to the 7th plus c. Okay, I didn't do this in the last one. We could do this really quick. Though remember, a good check, take its derivative and make sure you get back to that original integrand. So if we do the derivative of our result, right, we're going to do a check. I would bring down the 7, so I'd have 1/14th multiplied by 7, x squared plus 2x plus 3 to the 6. We drop 1, and then chain rule it. Derivative of the inside is times 2x plus 2. Okay. Now 7 over 14 is 1/2. And then last, if I distribute the 1/2 in here, because it's all multiply, right? It doesn't go to this everything, just either here, which I can't do because I have the 6th power, or here. And 1/2 of 2x plus 2 is x plus 1. So we are right back to where we started. Good to go. Okay, that was the correct result, 1/14th, parenthesis x squared plus 2x plus 3 to the 7th. And then remember your constant of integration. I didn't even mention that, but derivative of any constant, right, c is 0. So, good to go. All right, you're going to get some problems with e. Remember that the derivative of e, which I mentioned in the last one, the derivative of e, oh no, I did ln, but that's okay. E to the u, we'll say, is eu times du. Okay, the e stays the same, but we need the derivative of the exponent. So in that case then, because we're looking for e to the u, we're going to let u be the exponent. U is x squared. Du then is 2x dx. Right, we have everything we need again. Sorry, every example I chose has a 2, but that's just coincidence. So if I had a times 2 here, I have 2x dx. Once again, can't just magically put a 2 in there, so 1/2 times 2 is 1. So we get 1/2 integral. This becomes e to the u, right? Eu du. And the integral of e to the u is e to the u. So last, substitute that x squared, e to the x squared plus c. And again, you could do a check, do its derivative. but it's going to work out. All right, last example. We don't have parentheses. We don't have a square root. We don't have an e. So what the heck, how do we proceed? Well, sometimes, like I said, trial and error, but I have a lot of practice here, so I'm going to skip the trial and error. That is going to be u. That's the ugliest part. That's my guess. Let u be the denominator, 3 minus 5x. du then is negative 5. Remember the dx. Once again, we almost have it, right? If we had a negative 5 here, then that numerator is du, and my denominator would be u. But I can't just put that negative 5 in there, so let's also divide by negative 5. So negative 1/5 integral du over u. This is that special integral. Remember that the integral of dx over x is ln, well, plus c. Right? So the integral of du over u is ln u. I often leave out these absolute values as I did over here. It is important. It is part of the rule. I won't ding you if you miss it on the exam, though, but my math lab will want it. Most problems, what they say is assume the natural log would be positive, the variable x or u would be positive. Because we can't do natural log of a negative, okay, that's okay. I'm focused on, can you integrate these things? All right, so u is 3 minus 5x. Make that substitution in here, and that's it. If ever your answers don't agree, remember we do have properties of natural log. Anything out front can go to the exponent if it's being multiplied. Anything in here being multiplied, we could change to a plus, right, to simplify. But ln 3 minus 5x, we can't not do anything to. A negative 1/5 as an exponent, I think is uglier. So I would prefer this answer here opposed to this variation here. Also, a negative exponent, I need to bring it to the denominator, and a 1/5 really means a 5th root, right? So now I'd have a fraction, I'd have a 5th root. I mean, it just gets ugly. So in this example in particular, I would leave it as is.